Good afternoon, everybody. Welcome to this year's SGT conference. For those that have been here before to the conference, I can report that Stoke is traditionally a hot and sunny place this year, as has become the tradition at this conference. So a warm welcome to everybody on behalf of the SGT. For hopefully is the first and last virtual conference. Today we've got three papers from Fred Aker from PaneraTech, Torsten Ulrich Zippi and René Müllermann from Celsius. Before we start, can I ask you all to turn off your camera and microphones? And if you want to ask questions at the end of the presentation, please write your question via the Q&A icon and I'll ask the question on your behalf, or alternatively press the hand waving icon. The conference will be recorded and will be available on the SGT website in the coming days. Can I also remind members of the committee to complete their Michael Garvey questionnaire. So if Fred's getting close to be ready, I'll start the proceedings by introducing Fred Aker. Fred is a graduate of the Hyatt White MBA program in the UK. A 34-year stint at Sorg landed Fred in Germany. There he started their CAD program in 1985, managed Sorg's interest in multiple joint ventures, including one with Henry Teichmann. Fred later took over marketing and sales leadership positions at Sorg. He joined the exciting and growing PaneraTech team in 2019, where he is vice president for the sales and marketing. The pandemic wiped out his extensive travel schedule, and he is now using a lot of his newfound time to take walks, particularly in the nearby Speculative forest. So over to you, Fred.
Okay, thank you, Nigel. Let me see if I still remember how to share my screen. Okay, share. Okay, Nigel, maybe you can confirm that you can see my screen in the right format. Oh, Nigel or Ian, can you see my screen?
Yeah, Fred, you can, it is displaying correctly.
Okay, good. Let me take a look at the time real quick, 14:18. Okay, good. I want to talk a little bit about our approach to Industry 4.0 and the part of the problem that we're trying to attack for reliable manufacturing on glass furnaces. And Industry 4.0 is a journey, it's not a destination. I want to talk about Radar's role in reliable manufacturing, and we believe it has a large role to play. I want to give you an overview of the technology, a couple of case studies, and then talk about our platform of solutions and how we're moving towards Industry 4.0. First of all, we have a single focus in the glass industry on the furnace, on the refractory health. 1 second, I'll change my pointer. Pointer options, laser pointer. And the reason for this is because if the glass furnace fails, you're going to have 30 to 90 days of business interruption. Anything else fails, normally the downtime is measured in hours to days. What is radar? Okay, first of all, radar on a glass furnace is a direct measurement. We can install sensors during construction, which I'll show later, and it's going to be a trend, or they can be applied anytime after. Most of our inspections are periodic inspections. We're measuring as a rule all the way up to the glass. We have widespread coverage. You know, if you're using a hook, you're looking at an individual area or a single point. What we don't do is we don't use temperatures, and we find that temperatures mislead. We're not calculating electrical resistivity. There's no interpretation. We are a measurement tool. Took us a long time to get here, and we're not the first people to try this. In the 1980s, the British glass industry tried using radar to measure refractory because it's such a logical application. In the 1990s, T&O tried and failed as well. And one of the reasons that we succeeded is just because we had a lot of patience, or this was all before I joined the company. The founders had patience. They started back in 2007, and they only commercialized this product in 2017. The National Science Foundation put money into this. OI contributed, Libby contributed. So a lot of money's been spent on developing this intellectual property. And this is the reason it took so long, is this equation right here. 1 mile is equal to 4 inches. And the same energy that you need to go through 1 mile of cold AZS and come back again will only go through 4 inches of hot AZS. But those 4 inches are enough to make all overcoating decisions. Now, we do have another family of sensors I'm going to talk about where the range can be 600, 800 millimeters for looking through insulation. This product has been commercialized for 4 years, and we've already taken over 725,000 measurements. And this is just visiting the customers once or twice a year. Our near-term goal, meaning 2021, is constant monitoring and touching our customers daily. And the more data we get, the better our predictions will be. These are some of our customers in flat glass. You'll notice NSG Pilkington. In the UK, we've done a lot for Saint-Gobain, for Guardian. Other types of glass in the UK, for Stotzley. I see Steve's on the call today. Ardot Group, Allied Glass. This is very important to us, and that is that the insurance industry recognizes radar technology as a best practice. FM Global is the largest insurer of glass plants in the world, and they consider in their lost product data sheets radar to be a best practice. And they're going as far as to recommend that during repairs that the steel be designed to reflect better coverage. Now, a lot of our customers, they're looking more at maintenance, and they're looking at metal lines or flux lines in the UK. What interests FM Global, they want to de-risk the furnace. They want to look into the bottom insulation. They want to look into the sidewall insulation. They want to know if there's a glass leak early. And I've even had FM Global ask German customers if they're using Smart Melter and asking what they're doing to de-risk the furnace for leaks. Good, why radar? Our customers want to make confident decisions based on data. They want to know, can they reliably fulfill customer orders? I have a client in South Africa. He'd been planning on stopping his furnace on June 18th. He's going to do an inspection next week to see if he can go another year. They're using it to find out if they can fulfill those orders in that year. He wants to save the CapEx. He wants to move it back a year. If I do have to do work, what is the maintenance scope? How much do I have to patch? How much labor and materials do I need to plan? Am I doing something behind some insulation? I can find out if there's active glass behind the insulation before I pull back anything. Good. What is a radar inspection? First of all, it's using field operated sensors, which I'm going to show you. But these sensors and these handheld, they don't tell you anything. All they do is they collect radar waveforms, which are then analyzed by our data scientists, radar experts, and we put together recommendations from furnace experts. These are the current sensors that we're using, and all of our current clients would recognize these. Everything fits into one single rolling case, 22 kilograms with 100% redundancy. There's 2 of everything. This is current practice. 2 families of sensors, as I told you coming in. One of them is for AZS, where we can touch what we're measuring. This would be the flux line. I got to change over the UK flux line, AZS throats, electrode blocks, bubbler blocks. And then we have what we call the furnace tomography, talk about ranges first. Soda lime blasts, we're looking up to 100 millimeters. High zirconia used on LCD furnaces up to 150 millimeters. I saw some people from the insulating wool business on this call today. There's some bonded chrome such as Cepro wool where we have visibility up to 200 millimeters. This is the latest sensor. This will go through the grillage without any need to cut it or to remove it. Now we're getting into the second family of sensors. This is the furnace tomography sensor, and this is looking at sidewall insulation and bottom insulation. Here's a good picture of the sensor in action. And when we're looking at a bottom, we're looking at maybe in a float furnace through the clay flux up to 300 millimeters, in some container furnaces up to 600 millimeters, some furnaces up to the paving. When we get the drawings from the customer, when we get the refractory stack up, we tell them in advance what our capabilities will be. But in any case, within our sensor range, if we don't see any glass, then you're going to have at least 2 years at that location without a leak. People or the industry believes the glass leaks happen quickly and suddenly, but that's just because this insulation is hiding problems. You're not seeing it on your thermal audits. You're not seeing it with your eyes. By the time you see a red spot, this is something that's probably been developing for a couple of years. Quick 16-second video to show how this insulation sensor works.
The furnace tomography sensor, used on the furnace bottom and sidewalls, operates from the outer layer of insulation. The furnace tomography sensor maps early-stage glass penetration and measures the resistance.
I stopped this on purpose, and I hope it's still showing. What's happening here is when you take a measurement, you're pushing a button on a handheld once, and it's sending 10 radar forms into the insulation package, and we're getting reflections back. And from every layer of refractory, we're getting a different timing and a different strength of the signal, and we're using that to determine the remaining thickness. Also, glass or metal infiltration, if you're looking at the bottom, has a different signature. And each of these measurements is taking up to 2 seconds.
Residual thickness of the insulation and refractory layers.
This is the current process. If somebody's interested in inspection, they would give us the basic data that we would tell you what our sensor capabilities are, and we would tell you what the cost would be. Then we have what we call onboarding. We're getting a few drawings from you, refractory stack-ups, binding steels. We're building a digital model of your furnace. This digital model is what drives the inspection. Then things move to site. Either the customer themselves or us label the furnace around the sidewall blocks horizontally, starting with 1. The vertical sections, we use the binding steel ABC going down. Then there's training. Before the pandemic, the training was usually in person for the first inspection. Then repeat inspections the customers would do themselves, with us only sending equipment. Now in the pandemic, we're doing a lot of remote teams training. We've developed videos. Daily during the inspection, we collect data together if we're on site with you. And this data gets uploaded to us twice a day, where we look at it for quality checks. Doesn't matter where in the world you are, with our data centers in Turkey and the United States, we will tell you what the quality of the data was. We'll tell you if any retakes need to be taken the next day because maybe the sensor wasn't flat against the refractory. Maybe there's an area that's particularly interesting, and we might ask you to take what we call refined mapping, measurements closer together to get a closer raster. And then 2 weeks after data collection is finished, we have a call with the customer and we talk about the findings. And this is driven from furnace experts, not from the radar people. I alluded to this. Our customers usually collect the data themselves, especially if it's a repeat inspection. We can send somebody to your site. Maybe you don't have the labor, maybe it's a first inspection. And we have a great partner network around the world that we rely on to help our customers collect data. We just did one a few months ago in the UK where we used Chapman Brack, for instance, and it was their first time using our equipment. It's very, very easy to operate, very easy to train. Good. 4 years ago, we were a radar company. We could tell you how thick your refractory is, but we wouldn't have known what that meant. It would have been up to you to interpret if you have to do some maintenance, if you have a problem. Since then, we've hired glass experts. And as I said, we're over 700,000 data points. We're on our way to 1 million data points. And the more data we get, especially on repeat inspections, the better our predictions. So now we're telling our customers what actions to take and when to take them. So we're no longer the radar company, but we're the maintenance advice company. We don't do maintenance. We're kind of a trusted partner. This is an example of us using our data to give a customer maintenance windows, a recommendation, and when he should do it. Good. How do we use all this data we've collected to help you? First of all, the first question is always, is maintenance necessary? We have customers coming to us thinking they need to do a bottom repair, and we can tell them, no, there's been no glass penetration. It's possible that your temperature is slightly elevated. Maybe there's a breach in the pavers, but there's no urgent reason. We have many customers that think that they have to overcoat, and we can tell them that there's nothing to overcoat. And I'm going to show you a case in the next slide. If maintenance is necessary, we help them scope the material and labor accurately so that they're only patching as much as necessary. Again, helping with the timing, risk and safety management. Do I have any glass in my bottom? If I have to pull back insulation, is there active glass behind it? And we help customers that have changes in their markets. We have customers making amber glass. They want to know, can we go to flint glass with a higher temperature? We have float customers making flint, want to go to an extra clear flint, an extra low iron flint. They want to know if the bottom can handle those temperatures, and we help them make those decisions. This is a case study from when we were still developing the product, and Elmer Sperry was behind this. He had decades of experience. Elmer had plants in the United States, Mexico, Netherlands, Portugal, and China. And his decades of experience and temperatures were telling him he had to overcoat this furnace. And we came in and we did a survey, and we said, no, Elmer, there's not a single block here to overcoat. And he believed this was difficult for him. He had us come back in 4 months. And red here indicates that there was an area under 50 millimeters. This is still not, for soda lime glass, a patching case. It's still too early. We start talking to customers about patching under 35 millimeters. And he was looking at the lower sidewall insulation and bottom, so he knew he didn't have any other weak spots. In the end, they pushed back the overcoating 1 year, and that's very common that we tell customers that they can push it back a year. In this 1 year, there's usually only room for 1 or 2 overcoats. This enables a longer total campaign. In the end, they melted 25% more glass than budgeted on this furnace, and it was the regenerators that took the furnace down, not the tank. Sometimes things go the other direction, though. This is a customer that was expecting to run 5 more years, and we found glass in his bottom in the clay flux, and they planned to do a repair after 2 years. We watched this glass, did regular monitoring, learned about how glass spreads in a bottom, hitting a colder spot, moving out horizontally, hitting a colder spot, moving out horizontally. Glass does not leak as quickly as the industry believes, and we helped them make another 2 years. They probably could have made it longer, but they had the materials there, they had the labor lined up, and they saved having an unplanned business interruption. At some point, this would have leaked. They might have had a fire from that leak. this was a big benefit, even if they didn't get the campaign they were hoping. This is a short 6-second video. I don't want to bore anybody. And this is 2 cases over time. And I'm going to help you a little bit. On the left, when I started, you're going to see that they're using light cooling here. You're going to see a bigger spread of glass than there is on the right, where it was invasive and aggressive cooling. Starting it now. And again, in my monologue, I hope that was visible on Zoom. This is a case where we're helping a customer manage a problem. They have this design in the deep refiner on multiple furnaces, and they're getting this glass penetration here. And we're actually helping them time periodic repairs where they lower the glass level, and they time this together with other maintenance. And, you know, it used to be people thought, leak in the sidewall, I've got an urgent problem. No, we've proven that you have a manageable problem. This is an interesting case in container glass. They often have steel plate here, and we cannot, radar will not work through steel plate, but we had them cut a representative sample, and you can see it over here, just large enough hole to take 2 sensor positions. And we told this customer that they've got active glass down to 130 millimeters from the bottom in a light insulation. We told them that they're going to need to shut down this furnace immediately. They said they had to run 6 more months for customer commitments. This is what the furnace looked like after 4 months. It was too late, it leaked. It did another 3.5 million euros of damages. People like to ask, what does this cost? And the answer is really simple. It depends. It depends on how big your furnace is. A tableware furnace is different than a float furnace. The area you want to inspect. Is it just the flux line? Is it just the throat? Do you want to do the bottom? Depends on what you want to do. This determines how long you need the equipment. Who collects the data? Do you collect it? Do I collect it? Does a third party collect it? And if you collect it, shipping costs, they vary wildly from different areas of the world. Deliverables. Within 14 days of the inspection ending, you get a report from us with our recommendations and our risk assessments. We give you a web software where you can take a look at every single measurement you made. This is a wonderful visualization of any glass penetration. And then we schedule a call with the customer to discuss our findings. Good, that is the present. That was the ghost of Christmas present. Now I want to talk a little bit about the future. Our goal and the road to Industry 4.0 is for the furnace to warn you to stop abusive practices before you have a problem. And how are we doing this? First of all, these are our current generation IoT sensors. These have been in use for over 5 years on some throats that you cannot access after construction. So that was the driver back then. It wasn't Industry 4.0. It wasn't industry or Internet of Things. It was just, this is our last chance to get sensors on here. Talking about IoT sensors future, we have a new series of sensors which can be installed during construction on high wear areas, doghouse corners, etc. We can install them during the campaign to constantly monitor areas of concern. Our sensors can survive constant temperatures of 1300 degrees Celsius. We're currently piloting these in the steel industry. In the steel industry, the application we're using is on a stainless steel. The refractory life is measured in days, not years. And we're going to move these into glass in late 2021. These IoT sensors are game changers for us. Currently, we're visiting most customers, as I said, once to twice a year. We might be visiting the customer more often, but each furnace 1 to 2 times a year. In the future, we can touch these customers daily. We have a low cost per sensor. We have an increased sensor range, and we're not missing much on the current sensors to be able to look at chrome overcoats. And with these new sensors, we think we're going to be able to do it, or at least we're going to say it may be possible. But independently of that, we're working together with the major refractory suppliers to design chrome overcoats materials that are radar friendly. The more data we get, the better our predictions are. This milestone here is from March 31st. Since then, we're well on our way to 1 million measurement points. And at some point, this will be irrelevant because as we're doing Internet of Things, this number will just keep going up, up, up very fast. Good, but we're more than radar sensors, portable radar sensors. We're more than Internet of Things sensors. We also have a software platform. And the software platform for the refractory health platform, is what we call it, we're putting maintenance records in there. Smart melter radar data is going in there. You can add thermal audits to the software. If you see something, you can put your observations in there. Endoscopy reports can be put in a standardized format. And next, we're going to start adding production data. And they're actually already doing this in steel. Good. This just shows that we're doing more than the tank in the future, or even right now, regenerators, crown. We're trying to standardize data management. And the reason we want to standardize data management is we need to make machine learning possible. We're never going to get to that point where the furnace tells you to stop abusive practices unless we learn how to predict things better. And we're setting this up so the audit companies can put in their endoscope pictures themselves, the thermal audits themselves, and so forth. I know I'm about ready to get called down here real quick. The other thing the platform does is it establishes and tracks daily inspection routines, monthly maintenance, just to make sure that the plant is doing it so that the corporate can monitor that. Okay, conclusions. Solving the radar challenge in extreme heat was only the beginning. We need more data to realize Industry 4.0, and we're only attacking one part of it. That's the refractory wear. Affordable IoT sensors are one very important path forward. Standardized maintenance records are going to enable machine learning, and adding operational data in the future will help determine accelerated wear and even help prevent it. I want to thank you for your time, and I'm open for any questions.
Thank you, Fred. While we wait for some questions to come in, one that I have for you. The IoT sensors, are they available to buy or are they on subscription?
My current customers are always asking me if they can just buy the equipment and so that they don't need us. No, this will also be a subscription service. We still need to analyze data on our servers, and it's just our business model to protect the intellectual property. I see Renee has his hand up.
Hi, Fred. Thanks for the very interesting lecture. A question, it seems that we will install more and more boosting electrodes, more electrical energy feeding into the furnaces. Do you have any thoughts on those electrodes? Would it be possible with this technology to have a look at wear of electrodes, on when you have to advance electrodes, things like that?
Less so on advancing electrodes and on the wear of electrodes. Where we will come in handy is being able to put them on AZS electrode blocks, assuming that they're designed for it in their space. Many electrode blocks we can measure to see how that wear pattern is, and possibly adjacent to electrode blocks, because you have all these patterns, currents in an all electric furnace that erode the refractory a little bit differently than in a gas-fired furnace. so we can monitor some of those high wear areas for you.
But the electrodes themselves?
No, the electrodes themselves, no.
No, okay.
Looks like I'm off the hook.
Yeah, I think there's no more questions come through. I'm sure, there'll be opportunities for people to email you after the event. So thank you, Fred, for a very interesting presentation. And if you could drop out now, Fred, and I'll introduce Torsten Ulrich from Zippy.
Okay, thank you for the opportunity to present, and I'll drop out. Have a good
you.
show, everyone.
Yeah, Torsten started his apprenticeship as a professional electronic engineer with Zippy in 2002. He's been employed in the control department for a long time and carried out many installations and commissions in more than 30 building sites around the world. After his advanced training in the field of hardware and software engineering, Torsten contributed to the development of many in-house innovations and enhancements. For example, the Zippy batch charger, vibro tube, and the new software functions BZ Smart and Z Smart scraper. Since August 2015, Torsten is the person responsible in Zippy for the electronic engineering and process automation sales. In his private life, he volunteers in the local fire brigade, is engaged in the town council, and holds the chair of the local choir. So over to you, Torsten.
So thank you very much for the kind introduction. Sharing my screen. So you should have it. So thank you, everybody, for me having here. I would like to start my presentation with a very short introduction about the company Zippy. Then I will come to my technical point of the modern automation systems in batch plants and cullet recycling plants. And at the end, I will summarize again and give you a short overview on what is new on our side. So the company Zippy is located in Wertheim in Germany, which is a small medieval town 1 hour from Frankfurt, to those who don't know. Here you can see the company Zippy with the different departments. On the bottom right, you see our electronic center, where we develop and build our control systems for batch plant and also for the cullet plants. The company Zippy has a quite long history. It's a family-owned company, now in the 4th generation, led by Philipp Zippy and Günther Mühlner. The company was founded in 1920, so we have a bit more than 100 years of history. Our main business is the glass industry and especially the batch and cullet handling. We have a big range of products from small single machines like batch chargers, glass level controllers, and crushers, which you can see on the bottom, and also plant checks and small things. The other point are the complete batch plans and turnkey projects for them. And besides building the new plants, we also make modernizations of existing installations, and especially for the control systems, which is my part of the business. Here you can see different designs of batch plants, tower design, and serial or inline batch plants. The batch plant contains the silo feeding, and it contains as well the dosing and weighing, the mixing of the raw materials, and the transport to the furnace. For the material delivery, a lot of interlocks are necessary to ensure that the right material arrives in the correct storage silo. Entrance qualifications like RFID or QR codes can be used. This is coming more and more. And also between the different processes like weighing, mixing, and transport, there are a lot of interlocks necessary to guarantee a homogeneous batch. In order to manage this process, an electrical control system is needed for sure. In our control department, we have about 40 engineers and technicians to develop and build our customized control systems. Also, the commissioning support and training is done by our own engineers, as well as the customer support and after-sales service. But what are the requirements of a batch plant control system? This is the main question of today's presentation. What do we need? We should have an easy operation for the operators, easy to learn. The operation should be safe, reliable, and maintenance should be easy. And of course, the plant should have the possibility to be connected to any other systems, and the customer support should be available 24/7. So we're coming to the operation. Not all the informations are interesting for the operators. A lot of parameters are set once at the beginning during the commissioning, and they are changed never. So it's not necessary to show them on the screen. Too many informations are confusing the operators, and it makes the plant not easy to operate. So you should have well-organized screens and an overview with the most important information to have it as simple as possible. And another point is the automatic moisture correction, in order to put in a formula, and you will get the result what you put in, and you don't need to take care about any water content of your raw materials. And the operation or the control system needs a safe operation. As I mentioned before, not every parameter is important to be shown or changed, but the necessary parameters, they must be equipped with a user level protection. So for example, the formula data can be changed only with a higher user level. Additionally, there should be safety features to prevent a wrong setting by mistake. Of course, every setting is logged and reported with the timestamp and the operator who has doing the changes. To prevent any mistake on the silo feeding, a barcode reader for QR code or also for the RFID chips can be used to ensure that the correct silo is selected before the truck unloads. We hear that very often, that this is a big issue in the glass production sites, as some truck drivers just unload their tank or their dump and throw it in and fill it up. And it happens from time to time that the wrong material gets into the wrong silo. Of course, the operation should be reliable. That means only well-approved components should be used. We always need to remember that we have a 24/7 operation. It's not so easy to shut off for an hour or for 2 hours or for a day. Due to that, also hardware redundancy or software redundancy and modular components should be used. In the case of hardware redundancy, we could have one possibility of a hardwired redundancy with mimic screens. These mimic screens are mounted on the panel door, and they have some push buttons and LED lights to operate the plant in case of emergency if the PLC is not working. Another possibility is to have a redundant CPU or to have redundant SCADA system. So if one of those CPUs fails, the system automatically switches to the other without a stoppage. The same on the SCADA system. You have two redundant servers, so you can operate from every one, even if one is stopped. Another Another backup could be also a touch panel, which is coming more and more, especially by replacing the hardwired redundancy of the Mimic screen. So the Mimic screens are getting less and less, and the trust into the PLC controllers are getting more and more. This picture shows you some icons, an overview of the different electrical components used in a batch plant. So on the bottom, on the top, we have the weighing indicators, which are connected to the control system, to the PLC, which we can find in the center. The I/O modules as well as the PLC are shown on the center. And on the bottom, we have the operator stations to operate the plant, which could be servers, clients, web clients. So very wide range of possibilities there. In the center, you can also see that we have the Zipper teleservice where the plant is connected. So in case of troubles, you can contact us and we help. So this is something we say it's very important in a control system to have somebody in backup if something fails. The next thing is the maintenance. Maintenance must be done, let's say, every day inside a glass plant and also in the batch house. So we have, the control system should be equipped with safety devices like isolator switches on each motor to stop the drive safely and to give the possibility to do maintenance without somebody starting drive. And also that's what I mean, the interlocking of the process must be given. Maintenance on the control itself. So the control system should be equipped with approved components from major brands. And this gives you the availability of spare parts. If you have equipment from no name, it's hard to get spare parts in time, and if something fails, you're in big trouble. And also maintenance instructions and operator manuals must be available. What else do we have? Another requirement is the connectivity of the control system. Production data must be available. So in the older plants, we just have a printout of some reports, protocols, consumptions, but this is changing now to be connected to an ERP system or even to the cloud. So you can connect from everywhere. And if you're going to the cloud or if you're going out of your network, cybersecurity is getting a very important point, which should be considered at every time. With our app, we also developed an app which is called Be Smart. You can access your local data, your local SCADA system, to have data like dashboards or to have the scale parameters. Over a secured VPN connection, you will have the connection to your plant and all data will be safe. Here you can see the visualization of the weighing, of the dosing and weighing process. We have alarm messages which can be transferred. We can generate some dashboards with running times, with alarm message duration and so on. And also you have the connection to the scale itself, which makes a scale calibration, for example, quite easy, because you can take your mobile out to the scale and you can have the scale calibration directly on the scale and don't need to use walkie-talkies or something. And another thing is the customer support. The teleservice or the remote service is also a very important module of a modern control system. So nowadays, the automation systems using more and more high technologies, sometimes you really need us or the experts of the control system to solve some issues in the plant. So it's hard for the people on site to know all details of every plant part, as normally the people are not only responsible for the batch house. And also the teleservice via augmented reality, which is highlighted in blue, is coming more and more, and we also have this in the process already, and you can be in direct contact with our experts. So coming already to my review of a modern control system. For the batch house, it's important to have high-performed weighing modules, standard components, easy to replace, any kind of redundancy, hardware, software, both. You have smart access via different apps, or at least via some other systems. Charts and dashboards can help you to improve the productivity and access your information from everywhere. And also after sales service and remote support. What are the benefits of a new automation and control system? If you have an up-to-date control system, this increases your operation reliability and also the plant availability. You can be sure that you will have spare part supply. You have an improvement of systems performance, optimization for easy maintenance, and you can connect your system to a subordinate system like an ERP. And of course, you have a 24/7 support and can have an update or an upgrade of the control system even during the operation. This might not be possible when the system is too old. So what is new on our side? As I mentioned before, we developed the Be Smart app where you can connect to your SCADA system of the batch house and get some production data or even some other informations. This might be also helpful for the plant supervisor or for a foreman to make any formula modifications, some recipe changes. He can do that from everywhere. So you don't need to go to the control room. So in principle, if you have a job change or a color change or whatever during the weekend, the supervisor don't need to come on site. He can do it from his home. Another thing what we have new is the smart inventory system. This helps you to monitor the levels of the raw material silos. In order to that, you can have the data of your silos everywhere in the company and also outside the company. Whenever you have an internet access, you can connect to the system. This gives you also the possibility to install a vendor managed inventory, which means you give the responsibility of your raw material feeding or raw material delivery to your suppliers. So your supplier will connect to this screen and will see the level of the silo and also will have an forecast of how long the silo would last, and he can manage his deliveries by himself. This is something which is very untypical in the glass industry, but I'm sure this becomes more and more interesting during the next years as the local people are busy with other things. And my last point for the new things is the smart scrapper control system. So we developed the software functions to get some information from the IS machines to see how much glass is in production and how much glass is going down into the basement, into the scrapper. This allows us to run the scrapper with a much slower speed, and also to stop the scrapper for a while. If all lines are in production, it's no problem to stop the scrapper. And the advantages are I think, very clear. If you're not running the scrapper for such a long time, if you're stopping it, if you're running in a slow speed, you have much less wear. And I know a lot of scrapping conveyors which are running all around the clock. So you have a 24/7 operation, And with this function, it's possible to have maybe only 4 hours per day. It depends on your production. If you're not having so many job changes on the IS machine, so the most lines will be in production, and you can save a lot of wear and also some energy consumption. And due to the reduced wear, you also save some CO2. And I think this is also very important for the future. So now I'm done with my presentation. A bit faster than 20 minutes, but I'm open now for some questions from your side. Thank you very much.
Thank you, Torsten, for a very interesting paper there. We've got one question that's come through from Stuart Hicks of FIC, and he asks, can you expand on how you manage 24-hour support? Do you have experts on shift? And if so, is it a subscription service?
Yes. So we have an engineer, or let's say practically our head of the customer support. He have a mobile phone, and all the customers can call to an individual number to reach him, and he will forward this call to the responsible engineers. So we have always some engineers in backup which are not working during the shift, but they are available. So they have their mobile with them and you can reach them. And if something is really critical, they will do it immediately, and most things will be done on the next working day. And it will be a subscription service. Yes, we used to have this when we provide a new control system. If we provide a new batch house, we have this included in our contract during the warranty period, free of charge. And after that, if the customers, they require to have it, then they have an annual fee, of course.
Okay, then as Stuart just said, thank you, a good innovation. Got another question here from Nilesh. Apologies, I don't know you, sir, so I can't say where you're from. But anyway, his question is, do you have batch moisture sensor or probe which can be put after batch set wetting screw and before the batch charger? This will be hot environment. This will help maintain consistent batch moisture and compensate moisture coming from the cullet.
We have moisture measurements, but I'm not sure about the temperature. So if Nilesh could give me a direct contact, I can send him the information, but I don't have it available right now. So I think the normal moisture sensors we install on the sand, as usually this raw material is wet, and usually we don't have the cullets measured, but we also have some projects measured directly the cullets. But according to my experience, or if I remember correct, we never measured the moisture content directly in front of the batch charger. But this could be a possibility which we can check.
Okay, well, so we've got a little bit of time. Just one question from myself. Is it possible to upgrade the old scraper control system with a new Z-Smart scraper function?
Let's say yes, and it is possible, of course. So if you have already a strapping conveyor with a frequency controlled drive, it's quite easy, because then the regulation of the speed is quite easy. If you don't have this, maybe you need another or new motor and some modifications inside the control system, but it's not necessary to have a complete new scrapping conveyor or to have a complete new control system for that. So it can be installed also on older scrapping conveyors.
Okay, I think that's all the questions we've had. But so
Rennie's got his hand up, Nigel.
oh, sorry. All right, Rennie. Sorry, apologies. I was just looking at the bottom of the screen. So can you let Rennie in to ask the question?
Yeah, Nigel, if you don't want me to ask any questions, you only have to tell me.
No. So, I'm looking at the bottom of my screen and concentrating on the question and answer come through.
Which you should, in fact.
Yeah. Please carry on.
Torsten, thank you very much for the interesting information coming from Zippe. I saw that you did a lot of work on what I would call situational awareness, taking colors out of mimics which are not necessary to show, taking out data out of faceplates and things like that, which are not immediately important for the operator. So you are obviously heading to clean up process control screens and HMI. If you see that in connection with furnace control, are you also looking for some standardization on how colors should look like, how faceplates should look like, how alarms should look like, how they will turn up? Do you have any ideas? Could you share them with us?
Yeah, I mean, we are solution partner with Siemens for PCS7 for the glass industry, especially for the batch houses, and together with Siemens and also some other partners, we developed already some projects where we have a strict guideline where you can have the complete process with the same colors, with the same alarm messages, even the same tagging system of the alarm messages to indicate where the alarm is located. So we have this in PCS7 already, and we are changing our WinCC SCADA system, which is also a Siemens product. We are changing the same style to have a same or similar look and feel. So it's easy to have it on PCS7 or WinCC. On other systems, they are, let's say, quite unique. They are not so easy to compare, but we are working on having a standardized, or we have already a standardized indication or screens, symbols, colors, but it's not completely standardized together with the furnace suppliers and the cold end suppliers and so on. So this is still in progress, and I think especially together with Siemens, they want to have it in a standardized way to bring their products in the market, of course.
Okay. Nigel, would you allow another question?
Yeah, just a quick one, yeah.
Yeah, Torsten, I will later on in my presentation tell a little bit about LIPS. And we, as you perhaps know, Celsius is looking into LIPS specifically to find organic contamination and metal contamination in cullet. Since cullet rate will go up, do you have any ideas on checking the quality before you feed them into the furnace?
We had some test runs to have some colored indication on the fly, let's say, but it was not a very good result. So actually, we are not working on this topic.
Okay.
Okay.
But of course, for the cullet itself, before it enters the batch house, we have some recycling plants to get the ceramic or the stones out. These are in our product range as well. So the customers can have a recycling plant from us. But inside the batch house, we do not double check the cullets anymore.
Okay, thank you.
By moisture, if this is required. But it's not so easy to measure the moisture of the cullet because you have a lot of air in between. So
exactly.
You don't have the very good, the same cullet size, let's say. It's difficult to adjust the sensor.
Okay. Okay, thank you. Thank you for a very interesting paper. And for Rennie it was on the screen. If you we'll introduce Rennie Mullerman from Celsius. Rennie studied electrical and electronic engineering in 1968. He started his career in the paper industry as a technical assistant before switching to the glass industry in 1969. During his early years, he built a broad knowledge and experience in design and development of electronic quality equipment for container glass manufacturing, and was involved in the first implementation of first generation PLC and DCS systems, as well as electronic timing systems for IS machines. Rennie worked on several model-based prediction control (MPC) projects, as well as being involved in object orientation engineering method developments. He became responsible for process control inside the BSN group, and finally was responsible for the European plant process controls and forming electronics inside the Owens Corning group. In 2007, he left OI and joined Eurotherm by Schneider Electric Group, where he became responsible for the technical and commercial global glass vertical business development. Based on the Eurotherm and Schneider Electric portfolio, and together with his global glass business team, he worked on the electrification of the glass industry. In 2021, he joined Celsion and becoming their business development manager. So the floor is yours, Renee.
Okay, Nigel, thank you very much for the kind introduction. Yeah, okay, so as you could hear from Nigel, I came a long way, and you can see it with the color of my hair, I suppose. And I just recently decided to switch over from a huge company, being Schneider Electric with more than 150 people, to Celsion, to spend most probably my final years with Celsion. So let's dive into this presentation and put this away. Okay, I assume you can see my presentation, Nigel?
Yes, I can see your presentation.
Yeah, okay, so I was looking for some quotes, in fact, before I start putting this presentation together. And this is one which I used earlier. If you wait, all that happens is that you get older, which obviously, if you look it up, came from Larry McMurtry. But if you look a little bit further, wait a minute, why is it not moving? Oh, it also Mario Andretti, who obviously used the same quote. And he had also another very interesting quote, like if you believe that you are going fast enough, you might need to go a little bit faster. Okay, so a little bit on the background of Celsion. It's a relatively small team of approximately 20 people. We are into engineering consultancy, and we are operating from out of the Netherlands. We are located in Eindhoven, which is called the brain port of the Netherlands. There's a lot of startups and important technological companies located in this area. So I would say we are among a lot of other innovative companies in that area, and we are fully dedicated to glass. We have an academic and industrial background, so most of our employees have an academic background, and for me, I have an industrial background, and our slogan would be, we wish to contribute to a sustainable glass industry across all segments. Okay, so what are the threats for the near future? I would say ongoing increase of carbon emission taxes. That's a huge threat, of course. I don't need to explain. But recently it bumped up to 50 euros per ton of CO2. And if you look at the right bottom part of this slide, you find some predictions coming from FAVE in Europe. And they predict that CO2 per ton could go up to 250 euros per ton in 2050, perhaps even to 350 euros per ton of CO2. And then, of course, that would implicate that fuel switching and looking for alternative fuels is a must for the glass industry. Meanwhile, I think we face a lot of problems with unstable natural gas compositions. There are regions where hydrogen is already mixed into natural gas. Gas is coming from Russia, gas is coming from North Sea or from the Netherlands, for example, with a completely different composition. We are also forced to use increased amount of cullet. Most probably we have to start looking into fuel switching. There's a lot going on hydrogen, air or oxygen combustion. There's a lot going on biofuels, air and oxygen combustion. Electrification, of course. There's a huge trend towards putting more electrical energy into furnaces, and that will basically lead to all electric or hybrid furnaces. You all might have heard of the Furnace of the Future, an initiative of FEVE, of the bottle makers in Europe, which will design and build a furnace in 2000, which would need to be operational 2023, which will run on approximately 80% of electrical energy and 20% of fossil fuel, and later on hydrogen air or hydrogen oxygen mix. So new melting technologies. There are some rumors. It's not perfectly clear what OI is doing. At least they try to keep it silent, but they also came up with a new melting technology. And of course, there is a huge pressure coming from investors and customers towards becoming CO2 neutral. What recently happened in the Netherlands, and that's quite interesting political decision, or you could it's perhaps a decision coming from the people in the Netherlands, which the people against Shell in the Netherlands, they were in courtroom, and the verdict was that Shell has to drastically lower their CO2 emissions. That you can imagine Shell is a huge CO2 emitter globally, and now they are under huge pressure, and they have a verdict that they have to lower their CO2 emissions. So there's also a threat of an unpredictable political decision putting in front of you. Another example is, again, from the Netherlands. There's huge pressure in the Netherlands to reduce NOx emissions, because we are at the limit of our NOx emissions in the Netherlands. We even lowered our maximum speed on our highways from 120 kilometers or 130 kilometers down to 100 kilometers. So this is what can happen overnight, in fact. Okay, so let me first give you a short introduction. I will do a short trip down memory lane. I will tell a little bit about thermocouples, about LIBS, CO, O2 and H2O sensors, our new EBM software, data. That will be the final part of this presentation, and I will try to draw some conclusions. So first of all, this trip down to memory lane. If you start looking up when things happened in history, you will find that, for example, the first PID controller was already built in 1670 by Huygens, a Dutch guy. In 1822, the foundation of thermocouples was put together. In 1959, the first industrial control computer system arrived. Lasers, 1960, the first zirconium dioxide sensors, the oxygen sensors, in 1968. The first charge-coupled devices, 1969, Moore's law. At that time, in 1970, was talking about 1,000 transistors on a chip. And then in 2010, LIBS arrived. The introduction of Industry 4.0 is already almost 10 years old. And today, last year, if you look at Moore's law, it reached 50 billion of transistors on a single chip. So the developments seem to go very slow, in fact, because some things are moving fast, but what we actually start using is questionable. So let me explain a little bit from out of my own experience. In 1996, which is already 25 years ago, this is a slide which came from a first approach to do automatic furnace control, and it was quite successful. And we used data collection already at that time, and we start using regression methods to get predictions out of the data, and then to tune the system. We used at that time fuzzy logics, which was a product available for our DCS system. So we could use a fuzzy logic controller in that specific DCS system, and we used fuzzy logic to tune basically the regression calculation coming out of the data collection coming from the furnace. I assume that the method is still used at some of the facilities of Owens Illinois until today. But as you can see, already 25 years ago, the first approach took place to automate furnace control. In 2003, which is 18 years ago, we start fooling around with furnace cameras. And so we looked at, would it be possible to digitize a camera image? Can we de-angle the images? Can we recognize batch? Can we position, if we take out the camera out of the furnace and we take it back into the furnace, can we do a position calibration to make sure that if we need to clean the camera, that it gets back to the same location in the furnace, or at least that what we get out of those pictures is calibrated. And finally, it failed due to camera resolution. The camera was simply not good enough to do what we wanted to do. But the idea is already 18 years old, at least what we tried to figure out at that time. Today, if you look at camera technology, that came a long way. So I will show you some more slides on this topic later on. In 2003, we start looking into NOx prediction because at that time we had to come up with some NOx predictors, and we didn't want to install expensive sensors. So we figured out, okay, since we already had O2 sensors in our furnaces and we had DCS systems, can we use data coming out of the process to predict NOx? Basically, we started to build our first soft sensor. And as you can see in the graph on the right side of this slide, it was relatively successful. And you find the equation we used, a very relatively simple equation, which we used at that time in the bottom of that slide. That was a cooperation between TNO at that time, which was, if most of you will know that TNO was the company in the Netherlands, which Celsius came out of 8-9 years ago. So those initiatives were all relatively old, and we are still looking into them now today, in fact. Thermocouples. Of course, we start looking into thermocouples as well because we perceive them to be very expensive, and we start to understand that they show unpredictable and uncontrollable temperature drift. We checked thermocouples being in operation for 3 or 4 years, and at the time when we took them out and we did a recalibration of those thermocouples, we found drifts up to 10-15 degrees, so they were quite unreliable. So they were difficult to replace as well. So simply because of the fact that they are in most cases in very hot locations and they have to measure very hot temperatures, it's very difficult to replace them because you cannot simply take them out and put a new one in. You have to go through a procedure to heat them up and slowly lower them into the crown or into your glass in the forehearts. That was always a very difficult exercise to replace thermocouples. So the reflex was basically from maintenance to stay away from that as long as possible. But what happened to the drift? You can imagine that those data we got out of those thermocouples was not very reliable anymore. And most of the time, most of the time that of course led to bad maintenance. Having 3-level couples with 2 thermocouples in that 3-level element being down already before it was replaced. Okay, so again, we start looking at errors coming from those sensors. So the sensor as is, the platinum rhodium sensor shows an error, but also the connection and the wiring showed errors, but also the cold junction compensation in the system showed errors. And the mathematical equation to calculate errors is basically to square all the errors and take the square root out of it, and that will give you a total error. In some cases, we found extreme that the measurements which were shown on our process systems were far away from what actually happened in our processes. Today, with the furnace camera technology, and I refer to LandEmetec, and they shared a slide with me to show you today, but I assume that you all saw those slides before. Those cameras are capable to have multiple thermocouple spots on the crown, on the refractory material, close to the port, close to the burners, and things like that. And they are even, of course, they are also capable today to recognize batch patterns, look at flame hotspots and things like that. So it shows that camera technology came a long way. Now the technology is ready to take the ideas we had already 25 years ago and take them a step further. And of course, also the microprocessors sitting in those cameras and in the systems which are supporting those cameras came a long way. So as you can see, the guys from Amatec, they put a lot of ideas and converted that into software running together with their cameras. And now the question is, of course, what can we do with the data coming out of those cameras? What is important to feed into process control? How can we analyze what is coming out of the cameras and then use it in process control? Another interesting technology, which is still under investigation at Celsius, is looking into laser-induced breakdown spectroscopy. Basically, the idea came, of course, would it be possible to check a batch which is running from the batch house through the furnace? Would we be capable to checking what is on those conveyors and try to come up with some data specifically on organic contamination, metal and ceramic contamination of the batch which will be fed into the furnace. Redox, specifically in bottle manufacturing in dark glasses, is an extremely important parameter. And if we could have an indication of what's going on, what we are feeding in on organic contamination into the furnace, that would of course help us to control redox in furnaces. So far, I have to say, and I think that was already mentioned by Zip earlier, we are still struggling with the measurement. But okay, we will keep on investigating this, and most probably, if you stick to it, most probably we will soon be able to come up with some decent results as well. So what we like to do, of course, we would like to check if the right raw material goes into the right silo. It was already mentioned by Zippe. One of the major errors is, of course, that trucks come in and deliver their goods into the wrong silos. And that could, I remember a failure, I don't know, 20 years ago, which happened in the Maastricht facility, where a truck of polyethylene came in and dropped their material into our batch house, into a silo of our batch house. And unfortunately, that raw material had a similar weight as the standard raw material we were using in our batch composition. So we start recognizing when the damage was already done, and the polyethylene ended up in the furnace. And you can imagine what happened to the production at that time. So can we perhaps check if the recipes are still okay? Can we find errors in the weighing system by checking on the batch on the conveyor belt? Can we look at sulfur content in the finished products using the lips in another application? And can we control redox by trying to figure out the organic contamination on the conveyor belt as close as possible to the furnace, in fact? Another interesting development from Celsius, of course, is the CO sensor. So what we do is we try to take control of CO, but not only CO, but also O2 and H2O, so water content, and we measure with a laser device through the port of a furnace. So we try to measure as close as possible to the combustion process, and we try to have, let's say, an average value of the exhaust gases going through the port into the regenerator. We do believe that might be the best spot to measure specifically CO content. And but this laser device, which you are looking at this very moment, is capable to do 3 different measurements. And this in the traditional end port furnace or a side port furnace nowadays, you would of course like to measure CO. You might also have an indication. Might want also to have an indication of the O2 content, the oxygen content, and the H2O content. The device is also capable of measuring the temperature of the exhaust gases. In future, if more hydrogen will be used, the sensor can be easily recalibrated to measure other components in flue gases. This is a picture showing how the device is located. So it's outside the port, of course. There is a protective glass which has some purge air to keep it clean. So the laser is not really in situ. It's outside the port, looking into the port, through the port to the other side, where the laser beam hits a mirror and is bounced back into the instrument. So it's in a relatively safe position. Nevertheless, it has a jacket, a water-cooled jacket, to keep the instrument cool. And again, like I mentioned, you can measure 3 components in one device, and recalibration makes it possible to perhaps in future also measure H2 alone or some other components which we would like to measure. It shows no drift. And it has some integrated alarm signals. It has a comms, so it has a communication port where you can get all the information out of the instrument via Modbus TCP/IP. If you like, it can also have a Wi-Fi connection. It can be hardwired. Okay, so there's a full portfolio available from Celsius to install this instrument. There's also a smaller instrument available which is capable to measure only one component. So if you do believe that only measuring CO is sufficient for your process, you could also make use of the smaller and slightly less expensive device. Okay, so what are we trying to do? We would like to put this measurement into control. It has been done with zirconium dioxide sensors earlier, where you basically measure the content of O2 in the exhaust gases and try to, and of course, based on the O2, on the excess of O2 in the exhaust gases, you tweak the gas-air ratio. It is simply not sufficient to only measure the air coming into the furnace and the fuel going into the furnace, because specifically for air, for the oxygen content available at combustion, there's a lot of parasitic air going into the system. It's a ceramic building. It's not fully closed, so there's a lot of parasitic air going into the system. And the only way in checking and controlling the combustion process is by checking on the O2 content in the exhaust. We at Celsius, we took it a little bit further, because unfortunately, when you come very close to 0 O2 in the exhaust, the measurement becomes very lazy. It becomes very unstable. But that is exactly the point where CO starts to kick in, because if you have not sufficient O2 available at your combustion process, obviously you start producing CO. And that CO is very aggressive. It goes up exponentially, so that measurement is much more aggressive. And in a control system, we do believe that that CO is a more important value nowadays than measuring the O2. So this would be a simple line out of how such a system works. So you will have always a standard gas-air ratio controller or a gas-oxygen ratio controller. And with the measurement of CO and perhaps also O2 feed into the ratio adjuster, that will give a compensation value to the gas-air or gas-oxygen ratio controller, and will start controlling the air or the oxygen supply to the furnace until combustion is close to stoichiometric, where we just not start, produce too much CO and basically start up using all the O2. Based on those measurements, we restarted the idea of NOx predictors, because recently we got a question, could you give us a predictor, because we have two furnaces running on one stack, and we only have one measurement in the stack, and we do want to know if NOx is going up, or if anything happens to NOx, to the NOx measurement in the stack, to have an indication where that is coming from. Is it coming from furnace number 1, or is it coming from furnace number 2? I assume that we will use a similar lineup which we were using several years ago, for a NOx predictor, but now today, of course, we have more measurements, in situ measurements coming out of this laser sensor, which most probably makes the prediction more precise. Then, of course, EBM, also development, the latest development of Celsius. It's more or less a modeling tool, a simplified modeling tool. Let me see if this modeling tool where you, in a do-it-yourself action, can put your furnace in a grid. So you can basically put your furnace in a drawing, put it in the system, and then you can start to understand and to manage the energy uses of your furnace and of perhaps even your entire fleet. If you would like to benchmark furnaces against each other, this is a very helpful tool. It's useful in several parts across the entire production chain, in-house license or project execution. So there's a relatively simple licensing scheme in place. Additional training is offered for the tool, so it typically takes you 2 days to get some training, but I looked into it. It's perhaps not as easy as possible, so simply because of the fact that you need a specific skill set to put your furnace in a model, but I was perfectly capable to do that in 2 short days of training. And of course, we will keep on developing this tool. And let me show you an example how that looks in how that looks in practice. Okay, so this would be the result coming out of this EBM. So if you would go into configuration, you could look around in your model. You could go into your modules. You go into combustion. You could go into a specific zone. You go into a burner. You change the gas rate, and the value is available, and you can put it in your basically your representation of EBM. Now you can run the model. It only takes seconds to execute because it's a simplified model. You can change the pool rate, for example, run the model again, and the system will come up with some predictions on the amount of energy, how the temperature profile will look like in your furnace, what will happen to outlet temperatures, what will happen to your fuel rate combustion, how much, what will come out of your flue gas temperature. So it will give you a lot of important information on your daily operation without going into the tiny details which we are normally using in our GTMX models. And if you install it in your entire fleet, which one of our customers did already, you can of course start to benchmark furnaces against each other. Although we all know that sometimes 2 exactly the same furnaces are not acting in practice exactly the same. So, but okay, as a benchmarking tool, is it's very handy to use as a benchmark tool, and it also suggests process changes to optimize energy consumption, and it can even give you some predictive maintenance indication if air leakages occur. Okay, so the final part of my presentation, I would like to discuss a little bit the use of data. Again, I looked at some quotes on data, and the first quote on this slide, I saw that at a customer in America at their meeting room. In God we trust, all others must bring data, and I think that's a fair statement. It was earlier mentioned by others presenting today. Data is really very important. There's a capital mistake to theorize before one has data. You can read for yourself. Okay, so data. What basically we all provide data with our sensors. With our systems, with our sensors, we provide data. What the customer obviously is looking for is for information. And if you look at systems today, what happens is that I don't know if you can see this correctly. Looks a little bit funny to me. Okay, but what you see basically is that if you look at a plant today, you find multiple databases. And I was intrigued by the story of Torsten from Zippe that they are start looking into to standardization of data and representation of systems. And I think that is exactly what we need to do. In earlier days, you go to a specific batch house supplier, they come with a system, they supply you with a batch house and they have their own database. If you go to a furnace supplier, they supply you with a furnace, they have their own database. If you go to cold end equipment suppliers, they will give you the equipment, they will have their own database, the IS machine runs an own database, and all is working perfectly, and all the knowledge of those different companies are all, let's say, they are all in those separated systems. So there's nothing wrong with those systems as is. The only problem is if you would like to look at correlation between processes, if you would like to find a correlation be coming from a glass defect, and perhaps would like to know, is this coming from my batch house? Then it starts to become extremely complex to get data together. Most of the systems are still not time synchronized. They have different naming systems, so it's extremely complex. All parts on itself work perfectly, but together it's relatively difficult. So what we are promoting, and what we should promote, all of us which should promote, is a one plant database. Let's all standardize on bringing what we as different suppliers, what we bring to our customers, that data is available in a centralized plant database, time synchronized, and with a standardized naming system, which in my opinion is very important. I had some experience in early days where we start looking at CO2 emissions, where we had to look at data coming from the batch house because specific amounts of CO2 is coming from the batch. But the other amount of CO2 emissions is coming off, obviously, from the combustion system in the furnace. We had to combine those two parts of information, of data, together to come up with a calculation on the total emission of CO2. And we start with a centralized database and with a standardized naming system. And we didn't have to spend any time on the reporting functions because the operators were perfectly capable to put their own reports together. So it shows that if you give them data in a standardized format located in one location, it starts to become really important and helpful for all people in a facility. Okay, so I don't need to explain why analytics are important. Obviously, there are correlations which we are not even aware of. So, and if we would have the data in a centralized place, then we can start using analytics and to start finding those correlations and improve our processes. Okay, so what are the upcoming challenges? Stricter emission legislations, of course, we mentioned that, zero carbon emission in 2050. Most of the regions, the global regions, signed up for the Paris Agreement, so we have an obligation to go down to zero carbon emission 2050. That will most probably implicate that we have to build and to design new furnaces. There will be more electrical furnace boosting in those furnaces, perhaps even all electric furnaces. Unstable fuel composition in meanwhile. So in this transition, we will face a lot of unstable fuel compositions, more cullet content. We have to recycle our material. We have to look at further weight reduction. We have to look at the hydrogen firing, perhaps even with oxygen. So what can help us? Extensive modeling of new furnace designs. Let's make sure that what we build, what has perhaps never have been built before, is as good as possible, that we take as much risk out of those designs, because failure is simply not an option. Rigorous model-based predictive controllers based on the modeling of those new furnaces. That's obviously a good option which Celsin is bringing to the market. The energy balancing model, which I presented to you. Let's improve, let's have more reliable sensor technology, and let's have more data, and have that in data management and use data analytics. Okay, so, and if all we have is opinions, let's go for mine. Thanks.
Okay, Rennie, thank you very much for that. A really interesting paper. We don't have any questions yet. Or does anybody want to jump in with a question?
I'd jump in.
Yep.
Okay.
Go ahead, Fred.
Renee, first of all, you're singing to the choir with data, 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 data. I was glad to hear that.
Today.
And is Celsium putting together this total plant-wide database, or who do you see doing this?
Yeah, I think that is yeah, okay. I'm only 3 months with Celsium, and of course I already start putting pressure on that, because I really do believe that it is extremely important to have that centralization of data. There are different products capable of doing that, but I think the bottom line is that the owner are the plants themselves. They own their data. It's not us. We are the suppliers. They own their own data. They have to make the decision and make a system available to us, and basically force us to put our data in a standardized way into their database. We bumped into, I only bumped into one of them, which were doing that, simply because they bumped into a huge disaster where they had to combine 5 different databases with different time, with no time synchronization. And they lost a lot of production simply because of the fact that it took weeks to get that data synchronized and do the analytics on the data. And then they took the decision and put a centralized database in place. I do understand that this is extremely difficult, because we all have our expertise more or less in the way we collect data, correct? But okay, we might need to let loose a little bit and at least make sure that what can be used later on in analytics is available to the end user.
But we need somebody that's at least big enough that can put the pressure on all the individual suppliers.
Yeah, there are. I know that there are. I don't. Of course, I came from Schneider Electric, so I know Wonderware with Historian, which is a product which was perfectly capable of doing that. Obviously, there are other. Siemens is capable of doing this. There are other suppliers capable of doing this. Perhaps the most difficult part of the whole exercise is that you have so much different data coming out of a facility. You have batch data, you have continuous data coming out of a furnace, you have image data coming out of the cameras of PaneraTech. Now, Fred, I was listening to your presentation. You come into a plant, you do an exercise, so you have data for 1 or 2 days coming from that furnace, and then you go out, and most probably you will come back after half a year or something like that, and then you have a small data set again available, and that data set actually would need, with the correct timestamps, should also be in that database.
Okay, thank you.
I think, Fred, and then I stopped for talking. Before we even start talking about Industry 4.0, let's get the data right.
Yeah.
Okay, that's very good. Thank you, Renee. Well, we're all here and Torsten's still online. I'll open it to the floor. Are there any questions for any of the 3 presenters before we close today's session? No? It looks like you've been very thorough with your presentation, that there's been no questions, but I'm sure over time there'll be people know who you are now and will be asking questions in a personal manner rather than in this forum.
Yeah, perhaps a final word from my side, Nigel. I do believe now that we are on this edge of change, where we are going into this decarbonization exercise, and everybody's talking about it. We started this conversation, I don't know, 5-6 years ago. Glastrend started the conversation in 2017 in Haarlem, where Heineken stepped in and with putting a lot of pressure on the bottle makers in the Netherlands and things like that. Now, finally, I think there's a huge awareness among the glass makers nowadays, and I do believe that there is a how to say, an obligation to all of us to get together and share what we have. I know that everybody is very keen on their own intellectual property, perhaps we should not be too afraid to get together and make sure that the next furnace generation, which most probably will be a complete new design, will bring us into the future and beyond 2050.
It's certainly, from my perspective, being the refractory guy, and this, the word hydrogen has gone through the roof over the last 3-4 months.
Mm.
If you'd have asked me about hydrogen, I'd have said hydrogen H2. I now know about green hydrogen, blue hydrogen, brown hydrogen, pink hydrogen. It's sort of, everything is hydrogen, and the whole world is looking at replacing fossil with hydrogen, which is going to have implications for everybody.
But also, Nigel, for you, if you put more electrical furnace boosting into furnaces, obviously we are in need of refractory materials with higher electric resistivity.
Yeah, but also, from my perspective, how did you make hydrogen, blue hydrogen? It needs refractories. It needs
exactly
fuels to make blue hydrogen. That's where the cost benefits of this whole model is going to fly or not.
We're all in the same boat.
Yeah. I'm sure, some of us are old enough to remember when we went from town's gas to natural gas, and all our homes were converted over. And there's probably going to be that sort of infrastructure change as well when hydrogen is introduced more and more into the natural gas system for domestic use as well as the industrial. But a whole different subject. Probably they'll be covered next week.
Yeah.
for next congress or seminar.
Yeah. Okay then. Well, I'll close that down now then. What's this, Stuart? Some of us are old enough to remember the changes from oil to gas. Well, I thought you were old enough not to remember when they found oil, Stuart, but that's not for me to comment. So thank you all for your time.
Nigel, just before you finish, can you just remind the committee members to do the Garvey Award polling, and the 3 speakers are eligible for the Garvey Award.
Okay, so for the committee, hopefully you heard the instructions from Christine. Please vote, and likewise with the presenters. I'm sure she sent you the links for you to vote for the best paper of the conference to win the coveted Garvey Award, which we've been running now for unfortunately too long in terms of losing Mike Garvey. So on that note, I'll let you all get on with your professional lives, and we'll see you again tomorrow. Thank you.
Okay.